This lesson gives an overview and examples of compound inequalities. Compound inequalities are systems of inequalities connected by an AND intersection or an OR union. Let's solve the following. When you have a simultaneous inequality such as this, you can notice that it can be written in two parts, as that equation and that equation. So really, we are taking the intersection of these equations. Let's solve the following. If you solve this side for x, you'll add 1 to both sides, leaving you with 3 less than 3x. Divide by 3, you get x greater than 1. On this side, you'll add 1. You'll have 3x less than 6. Divide by 3, x less than 2. Now you want to combine that with an AND statement, an intersection statement, everything greater than 1 and everything less than 2. So the intersection will be just this common part, not including the 1 and not including the 2. So to give the final answer, you could graph everything between 1 and 2, or you could answer interval notation 1 to 2 with open brackets.
You can also treat this inequality as one entity. So you can try to isolate x on its own by doing the same thing to all three parts of the inequality. In this case, we'd want to add 1 to all three parts first. That would leave us with 3x in the middle, and then 3, and then 6. Now to get x by itself, you want to get rid of the multiplication by 3, therefore dividing everything by 3. The signs don't change because we're not dividing by a negative, and that leaves us with x being between 1 and 2, which is what we had as the answer previously listed.
Here's an OR statement, meaning this is a union of the answers of these inequalities. Here we can add 1, we get 3 greater than 3x, x is less than 1 with the division of 3. The other side says plus 1, and similarly as before, it's the exact same equation except it has an equal sign here. So it's 5 plus 1 is 6, divided by 3, you have x greater than or equal to 2. So if you plot those two, you have x less than 1, not including 1, and x greater than or equal to 2, including the 2. So the OR actually means to put them together and include all the points, not just the common points. So this actually gives us the resulting graph, and that can be expressed in interval notation as negative infinity to 2, not including, union 2, including up to infinity. Here's another one. This one's an AND, so it's an intersection. Let's subtract 5. We have negative 7x greater than 14. If we divide by negative 7, we have to change the sign, leaving us with negative 2. On this side, we can subtract 2. We have negative 3x less than negative 6. Divide both sides by negative 3, changing the sign, giving us x greater than 2. So if we look at the graph, x is less than negative 2 from this equation, inequality, and this one tells us that x is greater than 2. Now we want the intersection of that, but there are no intersection points. Therefore, the final answer is nothing. To graph it, you cannot graph any points that are common to both those inequalities. So you could say empty set is the solution. Here's another one. This one's an OR, so it's a union of both the solution sets. let's add 4 to both sides. We get 4x is less than negative 4. Divide by 4, you get x is less than negative 1. So x is less than negative 1 looks like this. On this side, we can add 4 to both sides, leaving us with 16. Now we can divide by 4, we get x is less than or equal to 4. So it's less than or equal to 4. So the union of those two sets is everything included in both of these parts, which means where everything is going to be less than or equal to 4. So our final answer is less than or equal to 4, which in interval notation is written negative infinity up to 4, including. Another example, this one's OR. So let's add 7, so 2x greater than or equal to 10, x greater than or equal to 5. On this side, we can subtract 7, we have negative x greater than or equal to negative 7. Multiply or divide by negative 1, changing the sign, giving us x less than or equal to 7. Let's look at what those look like. We have x greater than or equal to 5, and x less than or equal to 7. The OR is saying everything. So everything of this set and everything of that set. Meaning the whole number line. So our final answer would just be everything, which in interval notation can be written negative infinity to infinity. Let's take a look at an application example. Let P represent the percent of children covered by private insurance. M is the percent covered by Medicaid, and N the percent not covered. Using the information from the table, give the years that the following is true. So P greater than or equal to 68, which is 1998, 1999, and M is greater than or equal to 18, that's this one, and this one, 1999, 2000, and 2001. So and means the intersection of those years. So the common years leave us with just 1999. Try the next one. So the first one says P is greater than or equal to 68, which was here, here, and that's it. M is greater than or equal to 18, here, here, and here. But now it's an OR statement, so everything is included. So that would include all the years, and you can just list them out.